As we look into the next 15, 20 years, we need to ensure that when we are designing the solutions to net zero, that we're creating a just transition. And what I mean by that is we're not leaving anyone behind.
Hello, I'm Sue Nelson, and welcome to the Create the Future podcast, brought to you by the Queen Elizabeth Prize for Engineering, celebrating engineering visionaries and inspiring creative minds. Susan McDonald is an electrical and mechanical engineer by training, whose career has combined working on the national grid and alternative energy with voluntary work, including in the Arctic and closer to home with the NHS, the UK's National Health Service, during the pandemic. Today, Susan works for the global strategic consulting firm Monitor Deloitte as lead for energy transition towards net zero. In 2015, she was named the EY and Energy UK Young Energy Professional of the Year. In 2021, she was selected as one of the top 100 tech women in the UK. And earlier this year, won a Women in Science and Engineering Community Champion Award. That last award I mentioned there was sponsored by the NHS. So let's start with what you've been doing then during the pandemic.
Engineering is currently the heart of recovering from our immediate global challenge, COVID-19. And as one of many who contributed to the government-led, highly complex and collaborative response to COVID-19, it was my engineering and industry experience and capabilities that helped contribute to making COVID-19 home testing a fair and inclusive service accessible to everyone. And it was that application of system engineering and a code design approach that enabled me to drive the improvements into the service.
So what improvements did you make then?
First of all, it was enabling people to access testing in their home and looking across the system, thinking about how people could take that testing at home. Not everyone has access to an email address or the internet. So it's enabling people who didn't have that to be able to order a test and get their test result, all the way to ensuring that people with different languages or needing different support requirements could access instructions. And importantly, taking a test at home to ensure you were taking it effectively was enabling live video support for a number of people, both in terms of helping them undertake the test, but also to supporting those who were blind and partially sighted to take the test from ordering it all the way to returning their test and accessing their test result.
And you said systems engineering here, and this is something where this very logical, rational approach can be applied to so many areas to create this order of A, B, C, D, E, F, G sort of thing in terms of providing solutions effectively to no matter what the issue or problem.
Absolutely. And systems engineering is that interdisciplinary field of engineering and energy management, and really focuses on how you design, integrate, and manage complex systems over their life cycles. And it's that approach to engineering and the work of engineers is central to solving problems. Engineers seek to find solutions, and system engineering and systems thinking have got to be central to how we mitigate and provide adaptations to climate change. And this will need to embrace technology, policy, economics, and behavioural change to be successful.
And are you still working on this? Because you've effectively taken a career break to work on this, on the pandemic.
So I'm no longer contributing to the government-led programme, but I've taken that experience into my work now as energy transition lead and as an engineer as part of Deloitte's net zero transformation team. And really my experiences, what they did amplify is the importance of inclusivity and diversity in lived experiences in the designer process. And it confirmed to me it has to be part of reshaping our future. And the insights, the principles and lessons learned from the COVID-19 project are really principles that we can take forward to how we combat and adapt to climate change by being mission-focused, outcome-driven, collaborative, and really committed to a co-design model. So most recently, to kind of put that into context, I supported an organisation really help simulate and understand how customers' behaviours could change over time through the energy transition, and how they can use technology and solutions to help customers accelerate, but also make it affordable.
That's great. And it's a lovely use as well, isn't it? Like you say, of the lessons learned from doing something voluntarily that has an effect on what you get paid for, effectively. You're from Scotland. This is a country known for its wild weather. Is this why you became interested in energy from alternative sources?
First of all, I hail from Glasgow in Scotland, so I have to mention the fact that we had COP26 not only in the UK but in my hometown, which really brought to focus the importance of climate change. And in terms of what inspired me into engineering, I was a Scottish Space School alumni, and when I was 16, I got to go on a study visit to NASA in Houston, which was pretty exciting.
And this was Space Camp, was it?
It was, and it was...
Oh, I've always wanted to do one of those. Oh, I'm very envious. Yeah.
And it was just an extraordinary experience. And I think the one kind of light bulb moment, so to speak, was being able to speak to astronaut Michael Foley while he was on board the International Space Station. Meeting Michael back on Earth in Scotland, which it sounds bizarre when you say that, but listening to how he shared his views of what he was able to see down on Earth, you realise actually how precious and vulnerable the planet is, and the importance of protecting it. Whilst in Scotland, and where my family home is in Ayrshire, Scotland, I did some summer experience with a wind turbine manufacturer, and it was just my interest was sparked in renewables there. And I went on to, before Deloitte, I worked with National Grid, an international electricity and gas company. I went on to lead 12 of the UK's offshore wind projects. So I've got to say renewables is kind of in my DNA, and certainly it was incredible to see COP26 in Scotland. And I think for us in the UK and globally, there's a real momentum now of how we drive and accelerate to net zero. And I'm just, I think it's such an exciting place for future engineers and technologists, and I really hope it encourages others to pursue those fields.
What did you feel when you saw your first wind farm up close?
I think, first of all, as an engineer, you love to understand how things work, and the feat of how something has been designed, and coming back to that kind of systems design thinking and having seen it firsthand when working at National Grid, you realise the number of engineering and technician and design skills that have gone into design it. And I think if I was to paint my ideal future home, I would have sustainably living off my own onshore wind farm and hydro plant if I could. That would be quite something.
What are the challenges, though, of energy production from wind farms?
By its nature, engineering programs and designs are complex, but what's exciting is we have the technology there to accelerate to net zero. And I think what's important is it's not just about designing the engineering machine and looking at the power electronics and making sure it can operate in the grid. There's so much more interconnectedness in terms of the supply chain of materials, the planning, and more importantly, the involvement of the community where you're placing that technology, and ensuring that you're doing that with respect.
How do you do that?
Whilst I was at National Grid, when we were really understanding all the options to connect an offshore wind farm, in my role as a power systems engineer, I had to ensure with the technology and policy and customer teams, we're identifying a preferred connection that balanced the technical requirements, the impact on the environment and biodiversity, whilst meeting the needs of the future energy customers, and ensuring it was robustly evidence-based and represented value for energy customers. And I think most critically, as we look into the next 15, 20 years, we need to ensure that when we are designing the solutions to net zero, that we're creating a just transition. And what I mean by that is we're not leaving anyone behind. When we look at the UK, and we're not the only country, and the reliance on hydrocarbons in our systems, there's a real need to ensure as we switch from hydrocarbon to a more green economy, that we ensure that we also support the communities in both employment as well as opportunity, and don't burden specific parts. And that's why I feel really strongly that For us to be successful, we need to ensure that diversity and learning from lived experiences are part of that systems thinking and systems approach.
And when you were leading the coordination of these 12 offshore wind farm projects, I mean, that's quite a huge job, not least in terms of money. That's over £1 billion in terms of the project. That's quite a managerial job as well, effectively. Do you find that aspect as challenging as the engineering, or do you find one easier than the other, or do they both work well together?
First of all, I'm quite a people-orientated person, and I'd say, some projects have got a technical challenge to it, but from the start, stakeholders and teams are so important. And I've heard the terms recently, and I quite like them. I've heard the terms human engineer and business engineer, but effectively, engineers really focus on how do we help build a better future. And at the heart of that, it's about how do we build a better future for people and planet. And so for me, I really enjoy listening from different stakeholders because it helps you innovate. And it comes back to that systems engineering approach. So if you were to design something in a closed room, it's bound to not be effective or bound to not have that life value and enduring value to society. In those particular 12 offshore wind projects, the thrill of that was working with multiple capabilities and skills in different organizations to identify the preferred solution, and then working with the regulator to demonstrate the preferred option. And I think for me, that's what makes engineering so exciting. It's that it brings those both worlds together.
Now, you've been at Monitor Deloitte since 2016, but when you joined, it wasn't originally in the energy area, was it?
My experience the last 5 years with Deloitte, I focused initially on engineering complex programs. So my focus was around helping asset-intensive organizations in the water sector, in the rail sector, and energy services to shape, design, and deliver changes to asset maintenance and operations.
So that's infrastructure, effectively, is that right?
Yeah, that's right. And you really enjoyed those experiences. And now my focus is around, in our net zero transformation team, is focusing on shaping and setting a strategy to enable transformation. That's where we're helping to really set the business models and the deliberate choices organizations can make to really accelerate their contributions to net zero economy. And it's really exciting because what I'm able to do with that engineering program experience is make sure that the strategy we're setting is practical and that it's something that can be enabled through the organization, not only for communities, but employees as well.
Now, voluntary work, as we've touched on a little bit already, is an important part of your career. I was quite envious of this one you did in 2013 because it sounds so adventurous, but obviously serious as well. You went on a 10-day research expedition called Climate Change at the Arctic's Edge. What drew you to that particular project?
My Arctic expedition with the non-profit organisation Earthwatch was one of those bucket lists. I've always been excited to go to the Arctic, and it could be very much, watching those David Attenborough documentaries as a family, and just being inspired about understanding the impacts we all have around the global world. And going to the Arctic was very cold. It was minus 55 degrees Celsius with wind chill.
What?
So, yeah, and I was really fortunate. It was a time when I was at National Grid. One of my colleagues was an ex-Marine, and so I was very fortunate to do 2 days cold weather training with the Marines. So I was very prepared for the expedition. And what was incredible, I was part of an expedition with people, and on the first day I didn't know that after the expedition are great and continue to be great friends. But that experience of measuring the depth of the ice and the snowpack, really understanding the ice crystals, what that meant in terms of the sensitivities of that area, and worrying for me and for us as a planet, we were identifying that there had been a shift in the sites that we were monitoring. And so our work did contribute to contributed to the Arctic polar research work. And so it was both an exciting time to be there, but also one that really brought home the importance of how we all can play a role in averting climate catastrophe, and the importance of there are communities that are already being impacted. There's obviously something that attracts me to cold areas, but
that's living in Scotland, maybe.
It could be, and I'm really excited because I've just recently been selected to be a member of the community called Homeward Bound, a 12-month leadership initiative for women in STEM, science, technology, engineering, and mathematics. But excitingly, it culminates in a voyage to Antarctica together. What I really hope to achieve through my participation is, first and foremost, being able to collaborate with these accomplished women from diverse backgrounds in science and engineering and being part of this global movement to shape the future of our planet. I really hope that my participation can help amplify the critical role engineers have in shaping the future, and help others pursue a career in engineering technology and the energy industry, particularly in the context of decarbonisation and achieving net zero.
And do you think engineers' voices are being heard?
For me, engineers are at the heart of helping recover the current global challenge, COVID-19. And climate change is the challenge of our generation. And engineers have a crucial role in shaping and securing the future of our planet. And I think what has taught us the most over the last couple of years is the critical role that engineers, scientists, and technologies have in helping to address some of these global challenges. What's important for me, really, it's about how we encourage more women to pursue engineering, technology, and energy careers to help create an inclusive profession. Diversity and learning from lived experiences leads to more robust solutions. It's critical, not only because we've got to avert climate catastrophe, but to ensure the energy transition does not burden specific or vulnerable communities.
So how do you do this, for engineering to increase representation of marginalised communities in climate discussions? Is it all purely about communication?
I think there's, in terms of both encouraging people into engineering and technology and the energy industry, as well as involving people to participate, I think, first of all, when it comes to encouraging more diversity in an inclusive engineering profession, it's about role models. I can remember, I had fantastic mentors in my career of all backgrounds, but I remember the importance when I was able to see a role model who was a female in engineering, and really you feel that was achievable and really helped break down barriers around what the art of the possible was. That's really important, framing the art of the possible, and that we each have the ability to make an impact. And when it comes to involving communities in all parts of society, it's a co-design model. And that experience, whilst I was at National Grid, it was, stakeholders were involved in that design process, but most recently working with the Royal National Institute of Blind People, for instance, and other charity partners to inform and shape our improvements to how we supporting the government to create a fair, inclusive national testing service, really shows that we need to involve diverse and lived experiences and stakeholders at the front end. And it really helps lead to those robust solutions.
Now, you mentioned, the importance of role models, and you're quite lucky in a way in that effectively you also had role models closer to home because you're from a family of engineers, aren't you?
I am. So my father is an electronic and electrical engineer. My mother is a podiatrist. Science was very much in the house. I've also got an identical twin sister, Lynn, who's an engineer with UK Power Networks, and my younger brother, Ross, who is an electromechanical engineer with Scottish Power. And so we do joke, with our focuses in engineering and particularly the energy industry, McDonald energy, maybe something of the future. But I think what's great is, as a family and with my network of friends, what's really exciting is you've got that support and shared perspectives. It's a great conversation around the kitchen table at home, around, the latest things we've seen in the news, or just sharing stories. Because I think that's the thing where I really enjoy, although we work in the energy industry, we all have different experiences and perspectives. So I learn a lot from my parents, but my sister and brother as well.
That's great. And you're also an ambassador for the Queen Elizabeth Prize, so you know it well. You know what the work that it does and the winners and types of engineering that it's championed so far. What groundbreaking innovation would you like one day perhaps to win the Queen Elizabeth Prize for engineering?
Wow, that is a very tough question. I think first of all, what is incredible, and I remember at the beginnings when the Queen Elizabeth Prize of Engineering was inaugurated, and being able to celebrate incredible engineers in the same feat as a Nobel Prize. For me, the Queen Elizabeth Prize of Engineering is an exceptional award, and the past and present award winners just really show the creativity that engineering can bring. In the next 10, 15 years, I think what would be really exciting is, I'm going to be a little bit cheeky and have two themes. I think one that's obviously helping solve the energy challenge. So really helping us scale to low carbon technology, be that in fusion or storage. And the second is about how we enable services, both in how we live our lives, to really embrace choice and optionality, that it doesn't matter what support requirements you may need, that is just something that's designed in. And I think that's something that's really important as we look forward as engineers.
And I believe you have a motto: default green, default accessible.
Yes, and it's a simple one, but I think it's simple to try and be effective. I think as an engineer, we're in a very privileged position to be part of designing and engineering new products and services and engineering programs, that I think it's really important that, as all engineers do, we take that responsibility of, the choices we make have to enable that green, low carbon future. And we have to create and design a product and service that's accessible and usable for everyone. And that's the way that we will be successful in shaping a fairer, inclusive, greener and sustainable future. And it combines so many things, but my motto, to keep it simple, is yes, default accessible, default green.
Susan McDonald, thank you very much for joining me on the Create the Future podcast.
Thank you very much.
You can find out more about the Queen Elizabeth Prize for Engineering by following QE Prize on Twitter and Instagram, or visit qeprize.org. Thanks for listening, and join me again next time.